like across the nation. Basically, at any university, lots of universities will have eduroam, and it's like this. It'll work everywhere, kind of thing. It's pretty great. Pretty great. Okay. Oh, this is week 3 Monday. It's week 3 Wednesday, guys. And so let me fix this. Week 3 Wednesday. I don't know if you've noticed, all of my slides are produced in R Markdown. The same system I make you guys use for your homework is the same system I use for creating the slides. It's a good system. Okay.
You also make your syllabus. I
also make my syllabus. I pretty much do everything with R Markdown. I think it's my method of choice. Okay, but something's going on. All right. So the homework. Well, what questions do you have about the homework? I don't want to give you guys any answers and stuff. But let's see. Let's take a look at these instructions. What did I say? What's Oh, all right. So just a reminder, data camp is due Thursday. Okay, data camp is due tomorrow. So make sure you do that. Again, the intention being you do the data camp stuff before you do the homework assignment, because the idea being the stuff you do in data camp is helpful for completing the homework. Is that not the case? Does it feel totally unrelated, or I don't know? They're supposed to be connected, right? They are connected. Okay. All right. All right. Questions about the homework? Somebody said they were struggling with what part? Part 6. Okay. So part 6, data wrangling, exercise 1. It says easy. No, I'm just kidding. It says consider the following data frames with information about U.S. states from 1977. Okay, and so you create this thing, and then you also have to create this thing. Okay, and so it says create a scatter plot of illiteracy and per capita income with points plus labels of the 2-letter state abbreviations. Add a smoother. Use GG repel. Okay, which part's the hard part?
The GG repel.
GG repel is the hard part? Okay, so we go to the internet and we type in GG repel, right? So this is not like, I guess I'm not putting this in the slides, but you got to be able to search for help, all right? So you can go, you type in GG repel, okay? And you can click getting started with GG repel, okay? And so here is, and I think I linked to this thing, right? All right, and so this just basically, what are we doing? So, are we able to read this now? Like, understand what this says? So, you know, we're making a plot, ggplot, based on the data. We're mapping what? Weight to the x, MPG to the vertical axis, and we're adding a label. The label is, we're using the car name, okay? So on your thing, what would your label be equal to? How would you do your ggplot for part 6? For part 6, it says create a scatter plot of illiteracy and per capita income, right? So you got to choose one of those as your x, one of those as your y, right? So the hard part's not the join. Are we able to do the joining? Okay. All right, and then, so in the AES, we're going to map illiteracy to X or Y, whatever you choose, right? Per capita income to the other axis. And then what's the label? Plus labels of the 2-letter state abbreviations. So we're going to use the label's going to be 2-letter. Okay. And then how do we use ggRepel? Well, normally, okay, we do point, geom_point, color equals red or whatever color you want. And then normally for text, you just do geom_text, and it puts the text right on top of the dot. Okay, it centers the text right on top of the dot, which in some cases that's exactly what you want. And in other cases we go, oh man, this is hard to read with the text right on top of the dot. So all you do is you change it to geom_text_repel. And then it offsets the text in such a way that you can read them. Okay? And it tries to figure out where to offset them so they don't run into each other. Okay, and then what's the other thing you need to do? The labels come from geom_text_repel. Okay? I think that's all you got to do. I don't know. Does that kind of make sense? The usage? Try it out. Okay? You're good. We know you're good. Okay. Okay, well, let's take a look at the other stuff that I wanted to present today. Did I put this up on? This week's. Okay, let me upload today's lecture notes. Drag and drop. Okay, here we go. All right, so that should be it. Okay, so again, make sure you do your data camp homework, and then the other homework is due Friday. All right, I got office hours tonight. I got office hours tomorrow morning. Okay. I know the homework is due Friday. I intentionally don't have office hours on Friday. Okay, that's intentional because I don't like answering questions where students are stressed out right before the homework is due. So I want start working on the homework now. When you encounter problems, I'm happy to help you, but it's intentional that I don't have them on Friday. Okay. All right. So the reading for today still comes from chapter 6, but I think we got to talk a little bit about subsetting the tables in the first place. Now, we've been using the tidyverse. Okay, this entire class is very dependent upon the tidyverse, and I'm okay with that. Okay, that's kind of by design. Now, when I think you're scheduled to take Stats 20 at some point, right? Either next quarter or the quarter after or something. Okay? And when you take Stats 20, I guess depending on who you have as your professor, if you have Professor Tsang as your professor, excellent course, by the way, you will not be using you will not use tidyverse at all, okay? You'll be using base R, you'll be using data frames and all of that, okay? And it might feel a little bit frustrating, some of the homework assignments you get in Stats 20 and stuff. And what Stats 20, the point of that course is to get you to be able to do think kind of algorithmically in terms of like problem solving, right? So you're gonna get homework problems that says like, make a length function, okay? There's already a function that calculates length in R, okay? A length function that says like, here's a vector, how long is the vector, okay? There's already something in R that does that, okay? And you're like, so why do I have to make my own function that does this, okay? The whole point of that class is to kind of get you to think in terms of these problem-solving ideas, right? They want you to get you to be able to, take the tools you have and be able to recreate stuff, okay? And so, it's a different, it's an entirely different design philosophy regarding, what are we doing, right? This class, the focus is data analysis, okay? Working with data. There's very little in terms of like programming concepts, All right, everything is just kind of, this is the tool, right? And this is just the command you need to do. But I haven't given you kind of these programming, like, I know the homework feels like, oh, you got to think about this, but it's very much just figuring out how to use your tools, okay? So anyway, we're using tibbles, okay? Tibbles are basically souped up data frames. The base structure in R is called a data frame, and a tibble is like a slightly fancier version of it, okay? Kind of like the way RStudio is a slightly fancier version of R in terms of it just adds a bunch of nice little buttons and things that are really nice features. Tibbles basically take the data frame, add some nice features, add some nice things like it tells you this column is type double. This is a numeric value. This is a character type. This is a double type. Things like that. Because we got two types of numbers in R. We've got integers and we have type double. Doubles allow for decimal places. Integers do not. Okay? And then you've got different variables that look like characters. So you have character data, but you can also have factors. You can also have logical, which would be true and false. So anyway, this is the creation of a tibble. I got 3 columns, X, Y, and Z. And when we do that, it creates this thing that looks like a table here. Okay? And so tibbles are basically tables in the tidyverse. And again, this is something strictly related to the tidyverse. And we can subset, meaning if we want to just select one row or one column, you can do that with single square brackets. You know, I've shown you filter to just select certain rows, but sometimes you just want to subset the tibble, like you just want to select a few rows and things like that, okay? And you can, when subsetting with single square brackets, you can often also provide kind of coordinates. And the first row will correspond, first value corresponds to the row, second value corresponds to the column, right? So if this is our starting tibble, which I call df as kind of like a throwback to the data frame. If this is our data frame file, data frame. If I write this command, df square bracket 1 comma nothing, this means select the entire first row, okay? Because the value in front of the comma is the row, the value after the comma is the column. So here it says, I want the first row, and as for the columns, just give them all. Okay, you leave it blank, it'll just give them all to you. So this just selects the first row. Okay, now what would I do if I wanted to select the second column only? If I wanted to just select this second column, what would I write?
Space, comma 2.
Yeah, space. So we would have the single square bracket, space, comma 2. Okay? And that's exactly what we get, right? So if we do data frame, again, this is what we have. Second column, space, comma 2. And then it gives me, notice it's still a tibble, okay? It's still a table, and it just says it's a 3 by 1 tibble, okay? This original one was 3 by 3. It just says, hey, you're just taking out one column. It's still a tibble. It's just 3 by 1, okay? And this one was still a tibble. It's 1 by 3. Anytime you subset a tibble, the result is also going to be a tibble, right? Here, I said, give me all the rows. Which columns do I want? I want columns 2 and 3. Okay? You can use a colon. So colon notation is basically just give me a sequence of integers, 2 through 3, 2 colon 3. If you did 2 colon 20, it would give you, 2, 3, 4 up to 18, 19, 20. And that would work if you had 20 columns. If you don't have 20 columns, it's going to say that's not going to work, right? Let me just, an important thing is being able to read error messages. Let's, all right, so let me, all right, so here's my data frame, okay? So what happened here? I did 2:5. And what's the error message it gives? It says locations 4 and 5 don't exist, right? It says, hey, you give me a 3 by 3, and you're asking for column 4, column 5. That doesn't exist, okay? There's only 3 columns, okay? Can't subset columns that don't exist, right? These error messages are helpful, okay? Sometimes in R, we encounter an error message, and we get the error message, and we just, we give up, right? Because it gives us an error. But a lot of times when you read the error message, you go, oh, that's actually useful information, right? It points at you. It tells you you're trying to, somewhere in your operation, you're trying to select columns that don't actually exist, all right? So then you go, oh, what am I doing? Oh, yeah, I don't have a 4th and 5th column, okay? Similarly, okay? When you select a row, though, it's asking, give me the 4th row. What did it do here? It's saying, give me the 4th and 5th row. Okay? It's actually, it's trying it, okay? It's trying, right? So if I say, give me the 2nd through 5th row, it gives me the 2nd row, the 3rd row, and it treats the request for the 4th and 5th row as if these are just observations that we haven't recorded yet. Right? So it's a little bit, it treats the selection of rows a little bit different from the selection of columns. Okay? So when we ask for, hey, what's the 4th row, what's the 5th row, it just says, hey, maybe this data should exist, okay, but you just haven't collected it yet. All right? So it's a little bit different. You might be like, why is it working this way but not that way? That was a design choice by the designers of Tibble to return NAs rather than errors when you select rows that are what we consider outside of the range, okay? And the behaviors are different. DataFrame behaviors is different from tibbles, so I just want you to be aware. If you work with data frames in R, which is kind of the base setup, it operates, they behave differently, okay? If you provide 2 coordinates, okay, df square bracket 3 comma 1, it says go to the 3rd row, 1st column. 3rd row, 1st column. And it gives me back, what does it give me back? It doesn't give me back just the number 3 by itself. It gives me back a tibble. It's a 1-by-1 table where the only value inside is 3. There's a distinction, right? Because if I try to take this, okay, and if I try to add, say, you know, I can try to do operations with it, and it kind of works, but so I am able to do work with it, but the format is different than if so again, the result is a tibble. You can extract the value using double square brackets, okay? So single square brackets applied to a tibble always gives you back a tibble. Double square brackets will extract the value. Okay, so there's a slight difference there. Does that make sense? So one is you're getting back a table. It's a table with only one value in it, but it comes back kind of formatted as a table, okay? And then the other is just the value itself. Yeah. And that's the difference between subsetting and extraction, okay? So here we can extract the values, say in a column. There's a few ways you can extract it. You can say double square brackets 2 will give you back the 2nd column. And notice this is a vector of the characters A, B, and C. It's not a tibble, right? So when I said subset back to, subset the 2nd column, it gives me back a table, 3 rows, 1 column. ABC down the column. Here, I say extract the second column, and it says, okay, now we just have the characters ABC. It's not a table. It's not in the form of a tibble. Okay. You can also extract using $sign notation. You can just say, hey, give me column Z, df $Z. Give me column Z from the table, and it gives you 100, 200, 300. Yeah.
When you use $, is that exclusive to when you use the name of the column?
Yeah. So the columns need to be named if you want to use the $sign. Okay. So the columns need to have some kind of name. It is possible to create a tibble where you don't have a column name. Well, maybe there's a default name if you don't specify it. It might just be like V1 or V2 or something. Yeah.
So like you could do df $2.
Yeah, df $2 will not work because there's no name to. Okay. Now you can technically. You're not supposed to name things with a number, but if you put it in quotes, backticks, you can do df $backtick 2, and that would select a column that is, in my opinion, improperly named to be backtick 2 or something like that. Okay, so technically you can do that, but yeah, the $sign is used only for names. Yeah, if you do df $2, it's gonna complain. Let me just show you. Okay, so we can do df $Z. If I say $3, it says, I don't know how to do this. If we try to do this, it says, hey, there's no column named backtick 3, right? So there's a way to do this, right? You can also, if you want to select by, you can do square bracket 2. You can also extract. Oh no, it doesn't like that. So you can select, I want the second column. You can also put the name in quotes here. So you can say I want column name Z, and that will also work in quotes. So there's a few ways. You can always, all right, actually let's just do R tibble, okay. And again, the official documentation is always at tidyverse.org. So we got tibble.tidyverse.org, and there's, under usage, there's a lot of kind of demonstrations and reference, okay? So the reference is always kind of, how do you work with this stuff, okay? The official documentation is always, in my opinion, your best source of information, okay? You can go on Stack Exchange, you can go on different sites, and you'll have different experts answering these things. But in my opinion, the most reliable and trustworthy source of information will always be the official documentation. It just, it takes a little bit of patience and skill to learn to read official documentation, but once you're comfortable reading official documentation, that is by far going to be kind of a very important asset, okay? Is being able to read the official documentation rather than going to Stack Exchange and asking other people for your answers. Stack Exchange is useful, okay? It's a great place. You can ask questions and you can get answers. But generally, if you are able to read the documentation and understand that, and so, as you start on your journey towards data science, I really want to encourage you to put in the work, reading documentation, the official documentation from these places, and see it. And then you'll start to also appreciate packages that have good documentation versus packages that have bad documentation, okay? There's a lot of kind of wonky packages that, it's not very hard to make a package these days, and some of them have bad documentation, and you'll be like, ah. But generally, the top level sources, like the official documentation for R, the official documentation for the tidyverse, if you ever get into Python, the official documentation for like the big name packages like pandas and scikit-learn and those things, those are very well documented, and those are very, if you can read that stuff, very, very good, all right? You'll have these kind of mini little packages with bad documentation. It's very, very frustrating because nobody knows what's going on there. But All right, anyway, that's my rant about documentation. There's a, oh, okay, wait, I forgot. View quiz answer. You guys got to remind me about these stuff. Okay, what was today's view quiz answer pattern? Okay, first one is D. D as in dog. D as in dog is your first view quiz answer today. First view quiz answer. All right, remind me in like 5 minutes to give you your second view quiz answer, okay?
All right.
All right, okay. Maybe not 5 minutes on the dot, but okay. Nested data. So one thing about R and, well, the tidyverse is you're also able to create nested data here, okay? So look at what's going on here. We've got a column G, 1, 2, 3. So we're going to get 3 rows, okay? The first column G has the values 1, 2, and 3. And then what's the second column? The second column is data, and that's a list containing tibbles. All right? So the first one is a tibble with 2 columns and 1 row. Column X and column Y with values 1 and 2. The second tibble is a tibble with 2 columns, each with 2 rows, 4 and 5, 6 and 7 for X, and 4 and 5 for X, 6 and 7 for Y. And then the third one is a tibble with 1 column, 1 value. X is 10. And so notice this column data is a column of tibbles. It's a column, and inside that column, we're nesting little tibbles inside. Can we visualize this? Right? So you're making a table, and like within that one column, there's like little mini tables nested inside there, right? And if we wanted to, and this would probably be a bad design choice, you can further nest even more stuff in there, right? Then you get like the Inception tibble or something. Have you guys seen Inception? This was like a reference that people used to get, but now it's like a 12-year-old movie now, and we're like, oh, maybe we haven't even seen this thing. I loved it, but okay. So anyway, nest will create nested data, and then you can undo the nesting using unnest, okay? And then again, the official documentation is nest.html. So when you take a look at this data frame and I say, hey, let's go to the first row, second column, what do we get? It says, oh yeah, it keeps it as a tibble, right? It keeps it as, it says, hey, you're asking just for first row, second column. It returns the kind of the top level tibble, and it says, hey, it's a single cell in the table. It's a table of 1 cell, and inside that we've got a tibble. And we're like, oh, no, that's not what I wanted. I actually wanted to see what's inside. Well, then you have to do the extraction, okay? So here, I say, give me the first row, and within that first row, extract the second value. Okay, extract the second value there. And then it says, oh, what's inside there is a tibble. What's inside there is a tibble. And then we can further extract the values inside there if we needed to, but we have that. Is the difference between this and this okay? All right, so again, here is the original data frame, nested data frame. We could say, hey, I want to see what's inside here. What's inside there? I say, all right, give me the second row, all the columns. So that's going to give me this thing. And then within this thing, okay, the first element is 2. The second element is this tibble. We're going to say, extract out the second element. Extract that out. Gives me a tibble, the 2 by 2 table, 4, 5, 6, 7. All right. You can, yeah.
Is extraction only for column?
Extraction is anytime you've got, basically, when you subset with a single square bracket, it'll just give you a, like basically like a small tibble, a tibble of either like 1 cell, a tibble of 1 row, a tibble of 1 column. And then if you want to extract out the actual element that's in there, then you have to use the double square brackets. So you can apply it to a single cell. Okay, you can also apply it to a single column. You cannot apply extraction. I don't think you can apply extraction to a row. So you can either apply the extraction to a single column or a single cell. And the reason why you can't apply extraction to a row is because the row can contain different data types. So like this can contain numbers, and then the next row, the next column can contain characters, and the next column can contain something else. And it really doesn't like trying to mix different data types. Right? But if you extract a single cell, then you're not mixing data types. Yeah. Oh, second view quiz answer. Thank you. Second view quiz answer is the letter A. A as an apple. A as an apple. Yeah.
So is there a difference between doing double brackets 2 and single brackets space comma 2?
Let's see. All right, so we've got df1. Whoops, I got to create this. Where is my nested data set? Okay. All right, so I think the answer depends on the thing. Okay, so you got df1, and what was your thing? Question, single bracket, double bracket.
Yeah, double brackets.
So I think I can do double bracket 1 comma 2, and this will extract out the first row, second column. I can do, this will not work. This will work. No, it doesn't like that. You can do double bracket 2 itself, and it will give you actually a list of all the different tibbles. The 1, 2, that you can do that as well. Okay. Okay. Well, you can create a nested tibble. You can take this. All right. So notice this. You got G is 1, 2, 2, 3. X is 1, 4, 5, 10, and Y is 2, 6, 7, and 8. Right. So this is actually all the same data, and here we can call nest. And we can say, create a new column data where you're nesting X and Y into tibbles. And then it says, okay, we're going to take this and put it into a tibble. And it says, oh, look, G is 2 and G is 2. So we're going to take these 4 values, the 4, 5, 6, 7, and make a 2 by 2 table. And I'm sorry, the text got all messed up here. But it'll take this one with a 3 and also throw that into a tibble. It recognizes this as an NA. And so it actually keeps the preserves the NA, and it gives me 1 by 2 here. Okay. So you can call nest. Again, if you want more examples, go back to the documentation. Okay. But I got to keep moving along here. There's some more stuff I want to cover here. All right. So we can use nest to create tibbles, and then you can unnest it. Right. So if you have df1, which was the nested data, you can unnest it, all right, and then it produces this. So I want to just show you like another example. So I think early on, one of our examples was the Star Wars table, and we had different things. We had like the name and the height and the mass of these characters, and one of the elements, one of the columns names was films, and another column name was vehicles, and this was like, what films did they appear in? Okay, Luke Skywalker as a character at the time of the dataset's creation had appeared in 5 different films. And so that list, that list of 5 films is nested inside the cell for films. Okay, so this is nested data here, right? C-3PO appeared in 6 films. R2-D2 appeared in all of the films. And at the time of the dataset, it was 7. And so we've got a kind of a list of 7 things in there, a vector of 7 things. Okay? So if we want to get this out, what we can do is there's a couple operations. One is unnest. There's unnest longer. And what it does is it duplicates that row. Luke Skywalker, and it lists off the 5 films. Okay? C-3PO lists off the 6 films. R2-D2 lists off the 7 films, so on and so forth. So we are unnesting this. And again, anything that we're not unnesting, right? So we're saying unnest that column films, Everything else gets duplicated. So Luke Skywalker gets duplicated, but so does the column vehicles. And if we had other information, those would also get duplicated. You know, much in the way that like when you do pivot longer, anything that's not being pivoted gets duplicated, right? And so this is what we get. There's also another option. You can unnest wider, right? And this is going to add columns to your data set. So we took films, and we're going to say, hey, expand films to make new columns, right? And so it says, okay, well, the longest thing I could find was 7. That was R2D2. So every single one of these, it's abbreviating them. And so we get, you know, for Luke, we get Empire Strikes Back, Revenge of the Sith, Return of the Jedi, A New Hope, The Force Awakens, and then we get some NAs because, you know, his list was only 5 long. Okay? Whereas some of the characters have 7, some of the characters have 3, so on and so forth. Okay. So you can unnest wider as well. So you've got a few operations for working with these things. Yeah?
Doesn't it just do it in order they appear in the list, or is each column specified? It's column 1, just, I guess it's not all the same.
No, yeah, you can see here, it goes, it's just in the order that they appear. So here, we've got Revenge of the Sith. Is that the name of the film? Okay. That appears here, but then Attack of the Clones appears in the second one here and the first one here. So it's not like this is the column for Attack of the Clones and this is the column for, you know, that's a little bit more of a complicated operation there. Okay. There's a couple things about names that I think we've already talked about, and maybe you've already discovered it on your way of just kind of working with R. You can't have names that start with a digit. If you want to have a name start with a digit, you have to use a backtick, and that just gets annoying. Okay? Names can't have symbols other than the dot or the underscore. You can use dots to kind of, so if you can't put in spaces and things like that. The use of the underscore is the preferred method, right? So sometimes you'll see things like data.frame, t.test, and that was kind of the old convention. Today, almost everybody says, use the underscore, don't use the dot. Don't use the dot, okay? Names are case sensitive. I think you guys discovered that already. Getting data into R. A lot of times you're gonna have to import data from some data source, okay? You can read in pretty much any of these types of data files, CSV files, which is very, very common, but you also have tab-separated ones, delimited files, fixed width files, weblog files, tables, and stuff like that. There's also additional packages you can load if you're using a spreadsheet with Excel. It's called Read Excel. And then if you got, you know, a spreadsheet in the cloud with Google Sheets, you can also read that into R. Okay, it's got a way to kind of communicate to the Google Sheets cloud servers. You know, as long as the sheet has been published publicly. Okay, so like in Google Sheets, you know, most of your data is kind of by default set privately, but you can also kind of publish it. And once you publish it, I don't know. I better check the manuals here before I say so. Okay, there's a good cheat sheet here. If you click that, it's got a lot of information about how this how to use it. Okay, so this talks about, you know, what does your text look like? If it looks like this is what you should use. If it looks like this, you should use this. And then over here, if you've got Google Sheets, you know, this is, you got the URL for the Google Sheet looks like this, and you specify that when you read it in. So that's how you can get data into R. So here's an example. There's a CSV file located on GitHub, and basically you can just specify the URL. The URL is this big long string, and we can just do read_CSV on the URL. This uses the pipe. It's a little unnecessary to use the pipe here, but basically we're saying take the URL, this long string, and use it as the first argument for read_CSV. Okay? And it outputs some information, a little bit of information saying, hey, I read 1,728 rows, 16 columns, and it says, you know, when I did this, all the values are separated by commas. So that's great. And then here's to ask, show me the first few rows, the first 6 rows. Well, I get only the first 3 rows here, and this is what we have. Okay? And it reads it all in. Okay? Sometimes you have tables on a website, and you want to read this in. Okay? You want to read in tables from a website. So Wikipedia, the tables on Wikipedia work great. Certain websites, if you got a table, it will work well. A warning, this thing that the code that you see here doesn't work well on every single table out there, right? So on the internet, it's a little bit how people decided to format their table can vary, right? If they use a standard HTML table tag, generally this will work. You've got a decent chance of it working, not guaranteed, but if it's a standard HTML table tag, it could work, okay? And the package, you have to load this up. This is not automatically loaded when you run tidyverse. You gotta say rvest, okay? And this is kind of it's a play on the idea of harvesting your data, okay? Like you're a farmer harvesting your data. But, and so here you can just give it the name of the URL of the web page. In this case, it's how fast did people run the mile, right? You're running the mile, and how fast are they running? And it started off 4:28, and these are kind of amateur runs, and it's been getting faster and faster and faster, and things like that. So you got these different tables here, and back in the day, what you would have to do is you would take all of this stuff, and then you would hit Control-C, and then maybe you would open up an Excel file, and you would paste it, but then it would also copy over all of the formatting, and it's super frustrating, okay? Well, you can use R, and you can say, hey, go to this web page, go to this URL, okay? Read the HTML, right? I don't know if you guys ever read the HTML on the web page. Sometimes it's a mess, right? You can often right-click, and you can click View Page Source, right? The web page is written in HTML. It's written in all of this stuff. But the data, whoops, the data is all there, okay? It's all inside this table. And it says, hey, here's a row, here's the cell. The cell, one of the values is 428. And there's a link to another web page. And there's a picture of a flag. And it happened at this date, July 26, 1855. And it happened in this location, London. Hey, the next row is this and this and this. So that information is all written in this HTML, in this markup language. Okay? And your browser, your computer browser, the program that you use to browse the internet says, oh, I know how to read that. And when I do that, it should look like this. And our eyes go, oh, thank you. I'm so glad I can read this table and not that messed up markup language. Okay? Well, that's fine and all, but when you want to copy stuff, it becomes a headache. So rvest says, hey, I also know how to read HTML. Just tell me. You want me to read HTML? I'll read HTML. So you say, go to this web page, read the HTML. And then there's all sorts of stuff on that HTML. But we're saying, you know what? We're interested in anything that looks like a table. You can technically put in any other tag. There's something called selector gadget and stuff. And I don't want to get into it right now. But you can say, hey, I want you to find anything that looks like a headline. I want you to find anything that looks like a link. And you can also specify that. But for now, we're just going to say, hey, look for anything that looks like a table. All right? And it says, oh, on this web page, I found 12 things that look like tables. Right? We can say, look for anything that looks like a table, store those as tables, and says, how many did you find? And it says, oh, I found 12 tables on that web page. You go, whoa, 12? There's 12 tables? And you go, oh, yeah, there's 1, 2, 3, 4, 5, 6, I don't know. There's a bunch of tables on here, right? So it says, I found 12 tables, okay? And then so, if you want to get that out, there's a function. You say, okay, tables now contains that list of 12 tables, basically, or it's not a list, it's a data structure of 12 tables. And we say, hey, I want you to extract out the values in one of those tables. The function we're going to use that is called pluck. Pluck, and it comes from this per package, and we have to specify that. So we say, hey, use the per package, 3 R's here, per, pluck the first table. And it gets that table information out. Okay? And we can see that that information indeed lines up with what we see on the website, right? 428, Charles Westall, UK, 1980 or 1855, and indeed that's what we have. Charles Westall, UK, 1855, London and stuff, right? It drops anything that's a picture and stuff like that, but it gets that data out, right? You say, hey, I want you to pluck the second table, the table of amateurs, amateur runners, okay? And it says, oh yeah, all of this data. There you go, okay? So this is handy if you've got tables on sites like Wikipedia, certain reference sites like sports things and stuff like that. Some finance sites, not all of them, a lot of websites. So it's not gonna work on Facebook, okay? It's not gonna work on any site that you have to log in, this is gonna break, okay? So it's gotta be kind of something where you don't have to log in to get this stuff. The table's got to be formatted nicely. So this thing, when it works, it's great, but don't expect it to work on every single web page. Okay, so just be ready. So if you can get it to work, great. And if you can't, you know, you might have to find different ways. Right? There's a lot of tools out there. This is a very basic tool, for getting nicely formatted tables and stuff out of there. Oh, okay. Last view quiz answer for today is the letter B. B as in bear. B as in bear is your last view quiz answer for today. Okay, we'll end here, and we'll see you guys on Friday.